Dear students, I am Dr. Tamrakar from Bharati College of Engineering and Technology. I am teaching fluid machinery in B 5th semester. Questions. The diameter and stroke length of a single acting reciprocating pump are 12 cm and 20 cm respectively. The length of suction and delivery pipes are 8 meter and 25 meter respectively, and their diameters are 7.5 centimeter. If the pump is running at 40 rpm and suction and delivery head are 4 meter and 14 meter respectively, find the pressure head in the cylinder at the beginning of suction and delivery stroke, second in the middle of suction and delivery stroke, third at the end of suction and delivery stroke. Take atmospheric pressure head equal to 10.3 meters of water and F equal to 0.009 for both the pipes. Now the data given are diameter of cylinder is given as 12 centimeter equal to 0.12 meter. Length of stroke is given 20 centimeter equal to 0.2 meter. Crank radius is L by 2 equal to 0.1 meter, 10 centimeter. Length of suction pipe LS is given 8 meter. Length of delivery pipe LD is given 25 meter. Dia of suction and delivery pipe DS and DD both are 7.5 centimeter equal to 0.075 meter. Speed N equal to 40 rpm. Suction head HS is given 4 meter and delivery head HD is given 14 meter. Atmospheric pressure head H atmospheric equal to 10.3 meter of water, and coefficient of friction is given 0.009. This is given, and as we know, omega equal to 2 pi n by 60, so 2 pi into 40 by 60, so the value of omega is 4.188 radian per second. Radian per second. Now HAS, the pressure head due to extraction in suction pipe is obtained. HAS from the equation HAS equal to LS by G E by AS into omega square R cos theta omega square R cos theta. This is HAS. Putting the values here, this is 8, 9.81, and the areas are pi by 4 d square by pi by 4 d square, degree of suction ds square omega square r cos theta. So 8 by 9.81 into d is 0.12 by ds is 0.075 square omega square into r is 0.1 into cos theta. At the beginning, theta is equal to 0 cos theta. Now this value comes 3.66 cos theta. 3.66 cos theta. Similarly, pressure rate due to acceleration in delivery pipe is given by the equation HAD equal to LD by G into A by AD omega square R cos theta. Putting the values here, this is 25 by 9.81 into pi by 4 d square by pi by 4 dd square omega square r cos theta, that is 25 by 9.81 into d is 0.2 by 0.075 square omega square r cos theta. Putting the values here, omega and r. So this HAD is equal to 11.44 cos theta. 11.44 cos theta is the value of HAD. Now for the loss of head due to friction in section 5, HFS equal to 4 FLS by ds into 2G A by AS omega r sin theta whole square. Putting the values here, 4 into 0.009 into 8 by 0.075 into 2 into 9.81 into pi by 4 d square by pi by 4 d s square into omega is 4.188 into 0.1 sin theta, this whole square. Pi by 4 cancel. Now this value comes 0.225 sin square theta. Similarly, loss of air due to friction in delivery pipe is obtained from equation loss of friction in delivery pipe is obtained by HFD equal to 4 FLD by ds into 2G A by E by AD omega r sin theta whole square. Putting the values here, 4 into 0.09 into 25 by 0.075 into 2 into 9.81 pi by 4 d square by pi by 4 dd square into omega is 4.188 into 0.1 is r into sin theta whole square. Pi by 4 cancel. Now the value of HFT comes 0.703 sin square theta. Now the pressure head in the cylinder at the beginning of suction and delivery stroke. Here theta is equal to 0, so the value of suction HAS is equal to 3.66 cos 0 equal to 3.66 meter, and HAD equal to 11.44 cos 0 is equal to 11.44 meter. Pressure head in the cylinder at the beginning of stroke. Pressure head at the beginning of stroke is HS plus HAS. Below atmospheric pressure head, is equal to H ATM minus HS plus HAS meters absolute. So putting the values, this is 10.3, HS is 1 and HSS is 3.66. So this is 10.3 minus 4.66 equal to 2.64 meter. This is 7.66. This is 10 minus 4, 6.66 meter absolute. Now pressure head in the cylinder at the beginning of delivery stroke. Pressure head equal to HD plus HAD above atmospheric pressure head. Above atmospheric pressure head. So this is equal to H atmospheric plus HD plus HAS meter absolute. So this is 10.3 plus 14 plus 11.44. This comes 35.74. Meter absolute. Meter absolute. Now pressure head second, pressure head in cylinder in the middle of suction and delivery stroke. Middle of suction and delivery stroke. Here theta is equal to 90 degree. So HAS and HAD, HAS equal to 0, HAD is equal to 0, and HFS is equal to HFS is equal to 0.225 sine square 90 sine square 90, that is equal to 0.0225, and HFD equal to 0.703 sine square 90. This is equal to 0.703 HFD. Pressure head in cylinder at the beginning of suction stroke. Pressure head at the beginning of suction stroke at the beginning of suction stroke equal to HS plus HFS FS below atmospheric pressure head. Below atmospheric pressure head. So this is H atmospheric minus HS plus HFS meter absolute equal to 10.3 minus 4 plus 0.225 is equal to 6.075 meter absolute. Next, pressure head in the cylinder at the beginning of delivery stroke. That is equal to HD plus HFD meter above atmospheric pressure head. Above atmospheric pressure head. So this is HATM plus H atmosphere plus HD plus HFD, that is equal to 10.3 plus 14 plus 0.703 equal to 25.003 meter absolute. 25.003 meter absolute. Next, third, pressure in cylinder at the suction and at the end of suction and delivery stroke. End of suction and delivery stroke. Here theta is equal to 180 degree, so cos theta equal to -1 and sin theta equal to 0. So HAS equal to 3.66 into -1 equal to minus